Welcome. I am Velumani, Assistant Professor in the Department of Civil Engineering, Kamaraj College of Engineering and Technology. In this lecture, we are going to see types of supports, loads and beams used in civil engineering concepts. So, first we are going to see types of supports. There are three different types of supports. The first one is hinged support, then roller support, and third one is fixed support. These are the three different types of supports. So, a hinged support can be represented as like this in a diagram, and roller support can be represented like this in the figure, and the fixed support can be represented like this. So, these are the three different types of supports. These are used in beams which carries the support that we consider load and transfer the loads from the beam to the column. Let us see one by one. First see hinged support. A hinged support is a support which has two reactions, that is vertical reaction and horizontal reaction, which means a hinged support cannot be moved in the vertical direction and also in the horizontal direction. Let us take roller support. So, a roller support has only one reaction, that is vertical reaction, which means the roller support cannot be moved in the vertical direction, but it can move in the horizontal direction and also in the rotation. Let us take fixed support. So, a fixed support has three different reactions. One is vertical, then horizontal and moment, which means a fixed support cannot be moved in the vertical direction, horizontal direction, and also it cannot rotate. It is a rigid one. So, these are the three different types of supports. Then we are going to see three different types of loads which acting on the beam. The first one is point load. So, a point load can be represented in a diagram like this. The point load is also called as concentrated load. This will be acting at a single point of a beam. Then the second one is UDL. UDL is nothing but uniformly distributed load. A uniformly distributed load can be represented like this, or it can be represented as a rectangular load in the figure. And the intensity of point load will be capital W, and the intensity of UDL can be represented as small w per meter or per unit run. And the third one is uniformly varying load, UVL. Say a UVL, uniformly varying load, can be represented as a triangular load in a beam. It may be a single side or double side triangular load, and the intensity will be W per meter or unit run. Now, we are going to see different types of beams. There are 6 different types of beams. All these types of beams comes under determinate beam and indeterminate beam category. A beam is a horizontal member which carries load and transfer the loads to the column. A beam can be classified into determinate beam and indeterminate beam. A determinate beam is nothing but determinate beam is a beam which can be analyzed by using 3 equilibrium equations. The 3 equilibrium equations are sum of V equal to 0, that is sum of vertical forces is equal to 0, sum of horizontal forces is equal to 0, and the sum of moment is equal to 0. These are the 3 different equilibrium equations. By using these 3 equilibrium equations, if a beam can be analyzed, then that beam is called determinate beam. If we cannot analyze a beam by using 3 different equilibrium equations, then that beam is called indeterminate beam. In the determinate beam, the first one is simply supported beam. The simply supported beam is a determinate beam, and the second one is cantilever beam, and the third one is overhanging beam. These are the three different types of determinate beam we have. And the indeterminate beam category, there are three types. The first one is propped cantilever beam, then fixed beam, and the third one is continuous beam. These are the three different types of indeterminate beam. Let us see one by one. Let us take an example of simply supported beam. A simply supported beam has hinged support at one end and roller support at the other end. As we know, a hinged support has two reactions, one is vertical and another one is horizontal, and roller support has only one reaction, that is vertical. As we know, the three equilibrium equations, that is cap small r is 3, and the available the actual unknown reactions are 3, that is capital R is 3. So, by solving this, the kinematic indeterminacy will be 0. So, this beam can be analyzed by using 3 equilibrium equation. So, this is comes under determinate beam category. The second one is cantilever beam. A cantilever beam has fixed support at one end and no support at the other end. As we know, fixed support has 3 reactions, one is vertical, horizontal and moment. So, the kinematic indeterminacy will be 3 minus 3, 0. So, we can solve this problem by using 3 equilibrium equation, so that this beam is called as determinate beam. And the third beam is a overhanging beam. Overhanging beam is nothing but a simply supported beam may have projection at the one end or either end. So, as like simply supported beam, overhanging beam also have 3 reactions, one is vertical, horizontal at the hinged support and only vertical reaction at the roller support. So, the kinematic indeterminacy will be 0. So, this beam also can be solved by 3 equilibrium equation, so that this beam is comes under determinate beam category. Let us see indeterminate beams. There are 3 indeterminate beams. The first one is propped cantilever beam, the second one is fixed beam, and third one is continuous beam. Let us see first propped cantilever beam. A propped cantilever beam is a cantilever beam which has one more support at the free end of a cantilever. This support is called as prop. As usual, fixed support have 3 reactions, vertical, horizontal and moment. Including the prop reaction, the total reactions of propped cantilever beam will be 4. The available equilibrium equations are only 3. So, the kinematic indeterminacy of propped cantilever beam will be 4 minus 3, 1. So, we cannot solve this problem by using 3 equilibrium equations, because the available equations are 3, the unknowns are 4. So, we cannot solve by using 3 equilibrium equation, so that this beam is called as indeterminate beam. Let us take fixed beam as an example. So, a fixed beam is a beam which has fixed support at the either end. A fixed support has 3 reactions, one vertical, horizontal and moment. So, there are 3 reactions at one side. So, totally 6 unknown reactions are there in fixed beam. So, the kinematic indeterminacy will be 6 minus 3, you will get 3. So, this beam cannot be analyzed by equilibrium equations. So, the fixed beam will comes under indeterminate beam category, and the last one is continuous beam. A continuous beam is nothing but a beam has more than 2 supports or more than single span. Here you can see a beam, 2 span beam have hinged support at one end and two roller supports. So, there are 4 reactions will be there, 2 reactions at the hinged support, 1 reaction at the roller support and one more reaction at the another roller support. So, the total unknown reactions are 4. So, the kinematic indeterminacy will be 4 minus 3 1. So, we cannot solve this problem by using equilibrium equation. So, we need to go for special approach for solving all these indeterminate beams. So, these are all comes under indeterminate beam category. Let us see other type of beams in the next video. Thank you.